Okay, we're going over Theorem 2.4b Part 2, or actually it's called 2.1.27b Part 2, right here. So the argument of z times z bar needs to be the argument of z plus argument of z bar. And so the way we can prove this is first let z is a plus bi, z bar is a minus bi. And then the argument of z times z bar is going to be the argument of these two multiplied by each other. And so when we multiply by each other, notice that these two cancel out, this one, and then all we're left with is a b squared, I squared. And we know that I squared is -1. I'm looking right here is -1. There's a negative, so we're just going to end up with this positive b squared. And so the argument of any real number, because remember a and b are both real numbers, and so the argument of any real number is going to be 0. Also, well, actually, sometimes you can get -180 if you have a negative number, but this is the argument of something squared plus something else squared, so we know that these are both positive, so we end up with 0. Then what we do is we find the argument of z and the argument of z bar individually. So tangent of b over a, that's going to be the argument of z. And so we could find this pretty simple too. Just let's just put a point here, and that's going to be a plus bi. And so if we want to find that angle there, we can just say tangent theta equals opposite, which is b, opposite b over adjacent a. And then we want to find this angle, so we take the inverse tangent of both sides. So tangent inverse of tangent theta is going to be tangent inverse of b over a. And this undoes itself because it's an inverse function, and so we end up with tangent inverse of b over a. And so there we go. That's how I got this right here. And then we're going to go for the argument of z bar. So the argument of z bar, remember, that's just going to be down here. So that's going to be a and negative b. So tangent alpha of negative opposite is negative b over a, inverse tangent of both sides, tangent inverse, tangent inverse, and we end up with alpha being tangent inverse of negative b over a. Now remember that these a and b values are all the same, so this a and b is the same as this a and b, it's just that we have a negative. So these are going to be, especially looking at theorem 2.4a, we know it's symmetrical, so then also these angles will be opposite. They'll be, well, let's just put it here. Theta is going to be equal to negative alpha. Or you could also say alpha equals negative theta. Oh. And so, or the argument, this is also the argument. And the argument of z bar is going to be alpha, which is negative theta. So since we know that the argument, I'm looking here, the argument of z is this, so the argument of that is going to be the negative version of this, which we can now write as negative tangent inverse of b over a. So now we're just about done. So we have this part, we have this part. Now all we need to do is just add them together. So the argument of z plus the argument of z bar is going to be tangent inverse of b over a minus tangent inverse of b over a. And that's going to be 0. And that's exactly what we got here. Argument of a squared, argument, I'm looking right here. The argument of z is going to end up being 0. The argument of z times z bar is going to end up being 0. And the argument of z plus the argument of z bar is going to end up being 0 as well. So then we can conclude that the argument of z bar equals the argument of z plus the argument of z bar, because they're both 0. So 0 equals 0, and we're done.